Okay guys, in this particular lesson what we're going to talk about are acids and bases as a part of our chapter on biochemistry. So the first thing that we want to do is we want to revisit that phrase or that term electrolytes, and I want you guys to keep in mind that we talked about electrolytes when we were talking about Gatorade in class. And when we talked about Gatorade, we were looking at conductivity of the Gatorade. And if you remember from biology class when we did this demonstration, what happened was that the Gatorade very easily conducted electricity, and the reason that that Gatorade conducted electricity was because of the ions, and that was because Gatorade contains electrolytes, and electrolytes are going to be substances that when they're mixed with water, which is a content of Gatorade, they release ions, and those ions have charges, and we should know that when we're talking about conductivity, we're talking about electricity, and electricity, we're talking about electrons, negative charges. So ions, if there are charged particles, our charged electrons are going to be able to easily move due to the charges in the Gatorade. So an example here of an electrolyte is NaCl, and NaCl is really just table salt. And when it mixes with water, what's actually going to happen is it's going to be able to separate into the sodium and the chlorine ions. Acids, the way that we distinguish acids specifically, is that acids specifically release hydrogen ions. So these are electrolytes that still are going to release ions, but more specifically, it's got to be hydrogen ions. And what we have here is that hydrogen ion. So hydrochloric acid, when it mixes with water, it's going to separate, and you're going to have the hydrogen ions that are going to be released into the water. The opposite is true of bases. What's actually going to happen is that bases are going to be those electrolytes or those substances that release these ions, but their ions are going to be able to combine with hydrogen. Specifically, what we're talking about is these OH minuses, which are referred to as hydroxyl ions. And those hydroxyl ions, you can see that if they were going to combine with a hydrogen ion, you're going to have a combination that creates water. So when these hydroxyl ions combine with our hydrogen ions, it kind of neutralizes out, so that base is kind of the opposite of what we're looking at when we look at an acid. And then we have salts. And salts are actually what we create, or what are created when that acid, for example, hydrochloric acid, and a base, sodium hydroxide, when they actually are going to combine, you're going to end up with the substances recombining, and as they recombine, what you get is water, like I talked about, and that salt. So as we can see, that as the hydrochloric acid separates, we get hydrogen ions and chlorine ions, and as the sodium hydroxide separates, we get sodium ions, and you have here that positive and negative, and then you have hydroxyl ions. So what's going to happen is the sodium and chlorine are going to combine, and the hydrogen ion and the hydroxyl ion are going to combine. So you're going to get water and a salt. And if we think about it, that combination of acid and base, that's what we're talking about when we're talking about buffering, right? Being able to kind of balance out pH by combining acids and bases. And the reason that it kind of balances out is because we create that water. So when we look at our hydrogen, when we look at our pH, the important thing to recognize is that in pH we're really measuring the hydrogen ion concentration. And pH kind of puts it in a nice easy scale, that scale being 0 to 14, 0 to 7 to 14, above 7 being a base, below 7 being an acid. And then we have the idea that, like I said before, that water is going to be neutral, that number in the middle, that's 7. So what's going to happen is that solutions that have more hydrogen ions than hydroxyl ions, so remember hydrogen ions being the H pluses, versus the hydroxyl ions is going to be considered an acid, while the opposite, those with more hydroxyl than hydrogen, are going to be a base. So if we're looking at our beaker of water, and please guys still bear with me about my drawing. If we're looking at our beaker and we've added a substance in, and that substance, let's say hydrochloric acid, has released tons of hydrogen ions, we know that it's going to be considered an acid. There may be some hydroxyl ions, but they're going to combine with the hydrogen ions to become water, and you're still ultimately going to be left with all of those hydrogen ions, that acid. And just the opposite if I drew you a picture for the bases. This is just a nice little picture that kind of gives you an idea as to what substances are exactly where on the pH scale. So taking notice of the fact that you may not realize it, but things like cabbage are actually slightly acidic, bananas acidic. I think tomato juice, apple juice, lemon juice, those are all vinegar, those are all pretty common sense. Knowing that egg white is actually somewhat basic. Sodium bicarbonate, that's our chemical name for baking soda. And in our lab, we use that baking soda with the vinegar when we buffered, right? And then just an example of how it is that we can apply pH within the body. And knowing that blood has an optimal pH range, and when it starts to fluctuate and move out of that normal range, that acceptable range, we have medical conditions that result. So for example, alkalosis and acidosis are going to occur when the body moves out of homeostasis. So if homeostasis is not maintained, right, these conditions are going to result. So alkalosis, alka should tell us alkaline, which is base, versus obviously acidosis being an acid. And if we look, right, this is going to actually be on the lower end of the scale, on the higher end. Now keep in mind, 7 is typically our neutral range, right? If we look, all of this is actually above 7. So even though acidosis, acid, it's still not within the acidic range. That's 7 to 7.3. That's still on the pH scale considered on the basic side of neutral, versus alkalosis getting slightly more alkaline, right? So just something to keep in mind. This pretty much wraps it up for our lesson. You guys have a lab that you've been working on. If you have any questions about acids and bases, please feel free to see me.